cheese. That's the way to remember.
Or grilled.
I eat grilled cheese. That's great. That's the order going away from Jupiter. Yeah, you need to remember everything. Nothing I say here is not important.
You what? Or I eat cake.
Here are the what we think the inside of these moons is like. Three of them probably have iron cores. Callisto does not. There you see possible water on Europa. It doesn't show possible water on Ganymede, but scientists think that's true. So let's talk about Io first. This was the first moon they looked closely at, and when they saw it have volcanoes, the scientists just went nuts. They were like, no way. It's got volcanoes, man. Active volcanoes. The most powerful in the solar system. Io is incredibly geologically active. Volcanoes are seen spewing lava on its surface. It has a smooth surface because any craters or cracks are filled in by lava. So they were expecting to see a bunch of craters, and there's not. Any crater that ever formed gets filled in by lava. There's a few, but not many. So why does Io have volcanism? That's what we're wondering. And here's the reason. Io is active because it's tugged by the gravity of Jupiter and Europa, its closest neighbor, into odd contortions of its surface, building up much internal heat. Let me explain to you how this works. Can I borrow this, Lindsay?
Sure.
Thank you. Let's pretend this is Jupiter. And this is Io. Now, the orbit of Io isn't perfectly round. It's actually pretty elliptical compared to a lot of orbits. And so at times it's closer to Jupiter, and then at times it's farther away. I'm exaggerating. And when it's farther away, Jupiter's gravity is less. And when it's close, Jupiter's gravity is more. And so, do y'all remember tidal forces? We talked about tides, and like the moon causes the Earth to have a bulge in it that goes this way, and that points towards the moon. If the moon's over here, the tides kind of bulge. There's one going out this way, one going out that way. Well, when Io comes close to Jupiter, there's a tidal bulge. But Io is a solid rock. It doesn't have any oceans or anything. The entire planet kind of gets squeezed into an egg shape. And then when it goes away, the squeezing stops. And it becomes round again. And then when it gets closer, it's egg-shaped again. And then when it's here, it's round again. And so it's like taking an entire planet and squeezing it like this every time it goes around Jupiter. And that creates a huge amount of heat. Anytime you have movement and squeezing, if you were to take just rub your hands together, you can feel the heat that's created. If you take an entire planet, an entire moon, and are squeezing it and letting it go, it builds up a huge amount of heat. Also, there's another planet, there's another moon, Europa. That's a little bit further out. Here's Io, here's Europa. Io will move past Europa and get pulled on a little bit by Europa. And that also distorts the moon a bit. It also distorts Europa. And so this elliptical orbit and another nearby moon is always stretching and squeezing this moon, and it creates a huge amount of heat. and melts the inside of the planet into lava, which comes, due to convection, comes shooting out. It makes huge volcanoes. Isn't that great? Look at the volcano. Look at that. This is an actual photo taken by a craft flying past, and that's a huge volcano. Shooting stuff way out above the surface. Look at that volcanic plume. And there's another one going off there. If we had a volcano that big on Earth, it would take up much of the entire United States the comparison of that size to how big the whole planet is, or the whole moon is. This is the one. You're going to love this.
Orbiting Jupiter is the hottest moon in the solar system. Scientists once thought there could be little warmth a 500 million miles from the sun. But here, the gravity of Jupiter and its other inner moons squeeze, bend, and twist this world until it heats up like a furnace. This is a world of erupting molten rock, poison gas plumes. This is a world so hot it is melting before our eyes. This is Io. Your trip to hell.
The surface of Io is an extraordinarily inhospitable place. To an unprotected human on the surface, the first problem would be the lack of a breathable atmosphere. And there's always the danger of being caught in a massive volcanic eruption.
We will brave Io's hell to visit some 300 active volcanoes. The #1 attraction will be Io's old faithful, Prometheus, a constant plume that sends a tower of poison gas 50 miles high. There's Loki, the largest volcano in the solar system. Scientists still don't understand its structure, but it generates more heat than all of the Earth's volcanoes combined. And Amirani, 300 miles of oozing lava, the longest active lava flow in the solar system. Io produces 45,000 tons of lava a second, enough to pave all of the Earth's continents every year. It is hot, runny, fast-moving lava.
Lava on Io would flow like olive oil, and you couldn't outrun it. You could possibly ride a bike and get away from it on a bicycle if you could ride fast enough.
And if you had a mountain bike, you would take the ride of your life. For Io has mountains twice as high as Mount Everest. You need warm clothing, for away from the volcanoes, Io is more than 200 degrees below zero and full of snow. Take your bike near a searing lava flow, and you'd be burned on one side and frozen on the other. Where the hot lava hits the cold snow, you'd see a magnificent plume shooting up to 250 miles into the frigid darkness of space. When the plume cools, it returns to the surface as sulfur snow. Like a kaleidoscope, the sulfur changes colors with temperature and impurities.
Io is covered in red and brown and yellow and even green. It must be quite extraordinarily beautiful.
On the molten world of Io, one thing you'd want to do is study the lava, how it erupts, and how it cools. That's what these scientists are doing here at the Kilauea volcano in Hawaii. And if you could, what you really want to do is stick a thermometer right in a lava flow.
2100 degrees Fahrenheit. That's a typical temperature here in Hawaii, but on Io we expect lava to be about 500 degrees hotter, and that's something we haven't seen on the Earth for billions of years.
Io has the hottest lava in the solar system, over 2,600 degrees. The last time this temperature was seen on Earth was 3 billion years ago, when our planet spilled at least 4 times as much lava as it does today.
So Io's a chance to go back and look at the types of lava flows that have been dead from the Earth. So it's like Jurassic Park for volcanologists.
We will want to visit Io, but the risks are immense. It's not just the volcanoes. Here, Jupiter showers the moon with radiation 4,000 times the lethal dose. But scientists may have found us a safe home. Underground.
The main obstacle to successful inhabitation of Io by humans is overcoming the high radiation environment. And probably the best thing to do would be to seek refuge underground, out in something like this, a lava tube.
Io may be studded with empty lava tubes, basically old plumbing from its dormant volcanoes, and the rock above will act as a radiation shield. Keeping our exposure to a minimum, we would emerge from the lava tube for brief excursions, and we would look up to see one more surprise, the grandest light show in the solar system.
If I could be standing by a lava flow on Io and looking up at the sky, what I would see would be glowing volcanic gases, very much like the northern lights on Earth. It would be truly spectacular.
The aurora are created when sulfur dioxide gas ejected from the volcanoes strikes charged particles emitted from Jupiter. Gas hitting electricity, forming a gigantic neon light. It's one more reminder that the 95 moons hold the most exotic real estate in the solar system.
Cool. Kind of cool video.
Yep.
Well, what about Europa? Europa is also cool. Ice planet with vast networks of crisscrossing lines where the ice is cracked. The same thing goes for Europa as for Io. Europa also has an elliptical orbit, and every time Io goes by, it's stretched and squeezed, and it heats up the inside of the moon. And so we got basically an ice moon with a hot inside. And whenever you take ice and you squeeze it, it cracks. And so these cracks run along the surface of Europa. And if you could be on the surface and you could hear it, it doesn't have an atmosphere, so the sound couldn't travel through anything. But if you could hear it, it'd sound like just ice cracking, running all over that planet, all over that moon. And what happens when the ice cracks? Water from the ocean underneath comes up through the ice. And they've taken pictures and they can see where the water has come up and spread out and then refrozen. So they know there's an ocean under there. They don't know how far down the ocean is. It might be miles down. That water, when you crack that ice, the pressure, it's under high pressure and it comes shooting up and then freezes. And so there's cracks going along with water shooting up and refreezing.
Is it possible that the water could, or the internal heat could get hotter and then
Melt all the ice?
and then create an ocean?
Yeah, well, it's not hot enough the way it is. Maybe if you moved it closer to Jupiter, it would get that hot. Maybe they could do that one day. Probably take a lot of energy. There must be liquid water underneath the cold outer ice, an ocean perhaps 45 miles deep. If you're wondering, our oceans get about 6 miles deep. Europa's crust often breaks with water seeping up through the surface and then freezing, covering many cracks or craters. There aren't many cracks and craters on Europa. Most of it is smooth also because of the cracking and freezing and water. Scientists speculate that if there is an ocean of water, then Europa is probably the best candidate for harboring life in our solar system. Life evolved on Earth to use the sun for energy. But there are organisms that don't use the sun for energy at all. They're at the surface, they're deep down in the bottom of the ocean at these places called hydrothermal vents, where hot water comes up from the inside of the Earth, and there are organisms there that live off the nutrients in that hot water. And if the sun went out, they'd still be down there doing their thing. So maybe there's life on Europa in those oceans, and maybe there's a whole food chain, and there's fish in there swimming around, and who knows? There's a picture of Europa, and you see all these cracks? Those are all cracks from the planet cracking. More cracks. More cracks. I got all kinds of pictures. All kinds of pictures of cracks.
95 moons, each one offering a strange alien surface to explore. But in the shadow of Jupiter, there is one world that offers the ultimate possibility. The possibility of life. This moon is a small icy outpost called Europa. Our sun, a 500 million miles away, offers little more heat than a distant match. Europa is cold and desolate beyond imagination. On the surface, it is the last place in the solar system to look for life. But break through the ice, and there may be the first ocean ever found off the planet Earth. The first new ocean since Balboa discovered the Pacific in 1513.
I think the biggest surprise would be that a moon could have an ocean. An actual ocean that could be an environment suitable for biology. That's a real mind blower.
If I were to bet on one or the other, I would think that life would be more probable currently on Europa than on Mars.
I think to stand on Europa would be, to me, one of the most profound experiences of my life. It would be a place that might, under our feet, harbor life.
Europa would be a challenge to visit. Here, Jupiter rains a vicious hail of radiation that cooks the living like a microwave, and temperatures hover at 250 degrees below zero. To explore Europa, we will need something like a tank.
So this special vehicle for exploring Europa is going to have to be lead shielded to protect me from the radiation. I'm going to need a regulated atmosphere, plenty of oxygen to breathe, CO2 scrubber to remove what I breathe out, and I'll have to have a good supply of fuel, both to keep me warm and to properly explore this amazing place.
Europa's road is a bumpy one. There are 300-foot ice ridges that form a towering wall, and at the bottom, ice boulders block the way. You may not realize it, but you are driving on top of an ocean. Driving on a frozen ocean through a maze of tortured, jumbled ice as hard as concrete. Better drive carefully, for deep, dangerous cracks may be opening below your vehicle.
on Europa extend for 1,000 miles across the surface. In fact, some of them would go as far as from Los Angeles to New York. And as they propagate, they go along at about 3 miles an hour, just about the same speed as a person walking.
Europa is riddled with cracks deeper than the Empire State Building. Walking along, you might look in and see the ocean water rising from below.
On Europa, Jupiter exerts tidal forces that distort the whole body, so the whole moon gets stretched. When that happens, the surface gets stressed, cold, and cracks initiate. So you might have a crack like this on Europa, and it'll open and close every day, day after day.
Jupiter's tug is stretching and squeezing the inside of this moon, creating enough heat to melt underground ice. The melted ice forms a subterranean ocean, and warm water rises to the surface. On Europa, you can visit not just the first ocean, but these, the first icebergs ever found off planet Earth. You are now on a journey to the closest place on Earth to Europa. It is the icy, frozen Arctic Ocean. Scientists are coming here to the Arctic, searching for clues to the ultimate question: is there life on Europa? For if we can find life in this extreme environment, then we have a chance to find life on another world.
It represents, this frozen Arctic Ocean, just a spectacularly extreme environment that allows us to explore and test the limits of life on this planet, which therefore allows us to think about the limits of life elsewhere, or if it's even possible to have life elsewhere.
In the frigid Arctic, Jody Deming and Hayo Aiken search for the very limits of life. They drill into the ice, its temperature 20 degrees below zero, a temperature at which no living organism has ever been found.
Well, the most sophisticated way to look for life in these samples would be to take a section here unmelted and put it under a microscope in a cold room that's at this temperature. Stain it with a DNA-specific stain so that the bacteria light up for you, and then voila, there they are.
You are looking at living, breathing bacteria, found where no organisms should exist, in a place as close as we can get to Europa.
If I'm honest with you, I'm never surprised by what microorganisms are doing on this planet. They really have to be expected to do more than we ever think they're going to do. We have certain preconceived notions about what's too hot, what's too cold, what's too acidic, what's too. But every time we look and push a limit further and further, we find microorganisms happily perking along under those conditions.
With life thriving in the harsh, frozen Arctic, it's possible, perhaps even likely, that Europa's saltwater ocean, protected from deadly radiation by a layer of ice, will be home to the most profound discovery of all time.
In an environment like this, where you have a crack and water coming up and down every day, I could imagine several kinds of critters. You could have some things that hang in on the edge of the cracks. They want to be a few centimeters down to be safe from radiation. But as long as they're within a few feet of the top, they get enough sunlight for photosynthesis. Other organisms might want to float with the water and just come up near the top sometimes, and then the next day go on back down and just ride up and down with the suit.
Soon we may know if Europa harbors life. NASA scientists are currently designing a probe called the Cryobot to explore Europa's ocean. The Cryobot will land on the surface, but that's just the beginning of its amazing journey. For it will fire up a nuclear heater and begin a slow descent through the ice. traveling at a rate of 75 feet a day, it may take 6 months to make it through the thick ice. Like something out of a James Bond, the cryobot will split open, and a submarine armed with a remote camera will emerge into an ocean bigger than all of our oceans combined. The cryobot isn't science fiction. It is a current NASA research project. And within 50 years, we may be piloting a submarine looking for life on another world.
When I talk to my friends about hunting for life on another planet, they always imagine Klingons or something like this. I would be satisfied with slime mold. That to me would be one of the most profound discoveries that we've ever made.
It's an organic soup which was cooking for 4.5 billion years. That same soup on Earth cooked for less than 1 billion years and gave us life. So if I had to guess, I'd say there's a pretty good chance there's something very interesting going on in Europa.
I have a question.
Yeah.
So, if they're under the water, how will they get energy?
It's got a nuclear battery.
Never mind. Nuclear things cheat all the time.
So, I think what's going to happen is they're going to launch that sub. It's going to do its slide and its camera, and a big fish is going to eat it.
It'd be funny.
That would be awesome.
How do they know it's salt water?
Just based on the composition of stuff in the.
Well, at least you can study the anatomy of the fish that ate it.
That's right. That's right. But rocks are made of salts. So if it's a rock planet that also has ice in it, the rock would erode and release salts into the water, and so it'd be salt water. The only reason we have fresh water here on Earth is because the water rises up and then rains down, and when the water evaporates, the salt doesn't go with it. And so the only time you get the fresh water is when it rains back down, and it runs back into the saltwater ocean. Let's talk about Ganymede briefly for the last 2 moons are not as exciting as Io and Europa. Ganymede and Callisto are the last 2. Ganymede is larger than Mercury and Pluto. It's a big old moon. Ganymede has Maria, just like our moon does. The younger, lighter colored, the light colored part of Ganymede. Let's look at Ganymede again. I'll turn back to that. There's Ganymede. So the light colored part on Ganymede is the Maria. Ganymede had plate tectonics like Earth until 3 billion years ago, and it became too cold. You can tell that because Ganymede has evidence of plate tectonics like mountain ranges. Ganymede is too far from Jupiter and the other moons to have the internal heating mechanisms like Io and Europa. We've recently found some evidence, though, that that's not true. And it may be hot inside, and it may have a liquid ocean, too. The word is still out on Ganymede's liquid ocean. Pictures of Ganymede. This was the Galileo satellite that went by Jupiter. This is too long. Cool, that's what the surface looks like. That's pretty sweet. Huh. Nick Callisto even less internal heating, probably was never completely molten. And so Callisto, never being completely molten, does not have a core. You have to have been completely molten at one time to get a core, because that's when the heavy metals fall to the center. Callisto has a huge crater from a significant impact where ice thrust up ice waves froze in place.
Wow.
Here's this huge impact, bam! And it melted all the ice and made waves, and then the waves move out in the melted ice and then freeze in place. And so you have these melted ice waves.
It's called Valhalla.
Valhalla is the name of the huge impact.
I thought that was supposed to be a good place.
I don't know why they call it that.
And Odin.
Were you trying to take these notes?
Yeah.
Sorry.
It's like the lower side. Yeah,
Rose yourself.
Does the sun have a core?
Yeah, the sun's core is where this the fusion is occurring, and it's a lot different from the core of the planet. It's releasing huge amounts of energy and expanding at all times. So it's not really solid like.
The sun was never molten.
No, the sun is all hydrogen and helium gas. So it kind of follows different rules. We're going to talk about the sun next chapter, chapter 9. And we'll learn all about the sun. But it's not really molten because it's not solid, it's gas.
I just didn't know because you said the core. I think.
Yeah.
About the core.
Yeah, the core, a planet, a solid rock that becomes molten will have the metals sink to the middle. Okay. So read